Welcome friends, welcome back to our channel Crystal Learning. So today we will see the subject manufacturing technology. This question came in Telangana State Public Service Commission Assistant Executive Engineer exam in 2015. A very good question, and we have to see some details or some important information. If you miss that information, then definitely this question will be wrong. We will put the options wrong. So let's see what is the question and we will see the explanation. We won't go into the detail. I am giving in the starting also that here we are just seeing that what is the correct explanation of this question, okay? Because some terms and condition will be there. For that you have to go deeper in the subject to know the complete information about that concept. But here we will see maximum concept or maximum understanding that which option is correct for this question. Let's read the question. Question says, identify the wrong statement. First information you have to keep, it is asking for wrong statement, okay? Sorry. Related to yield criteria in metal forming. Second most important thing, you have to give this answer or option keeping the thing in your mind that it is asking for metal forming, okay? So let's see the option. That is stress along hydrostatic component do not cause plastic deformation. Deviation component causes deformation, means plastic deformation. And third is plastic deformation only when resultant stress reach von Mises cylinder, and Tresca is plane strain case. So this is true for this. And here main important points which we have to note down, or we have to see the concept that what is hydrostatic component, what is deviation component, what is plastic deformation, and what is von Mises cylinder, okay? So these things we have to get an idea about these things. So when you study these yielding failure theories in detail, then definitely you have the complete information about this question. So let's see some explanation. So first, if any arbitrary state of stress is given, that is sigma xx, tau xy, sigma xz, so then these can be decomposed into two components, that is hydrostatic and another is deviotric. Deviotric means deviation, same, okay? So these can be decomposed into two, that is sigma m00, then sigma x minus m tau xy. So this first state is known as hydrostatic and this second state is known as deviotric state, or it is known as pure shear state. Pure shear state. Okay. So this is known as. So what is the value of sigma m? Sigma m value is sigma xx plus sigma yy plus sigma z upon 3. This can be derived when you go and study this yield failure criteria in detail. Okay, we will see what this component do with the material. Suppose this is the cube, on this is a general state condition. So when you have decomposed this into two state stress, so first is where only sigma m is there, means normal stresses are there, no shear stresses. And in second case, it is denoted sigma x, sigma y, sigma z, but this summation or these things will come to be zero. There a term is there, that is stress invariant, that will be come to zero, and for this condition, whatever state stress condition satisfy this I1 or invariant, first invariant equal to zero, that is known as pure shear state. You can find this thing in theory books, okay? So now we will see what these two state does to the material. So here we see that hydrostatic stresses try to change the volume, or you can imagine these sigma mean values are like pressure exerted on the surface from all these three directions. So it will try to change the volume depending upon the tensile or compressive load. And this thing, that deviotic stress, as it is a condition of pure shear, so it won't change the change the volume of the material, it will change only shape of the material. So these are the two property of these stresses and the effect of these stresses. Let's read some condition about hydrostatic stress. Sigma m is like three equal components of normal stresses acting in all three directions, okay? So these are the value given, that normal P pressure is equal to sigma x, sigma y, or sigma mean equal to sigma y, sigma z divided by 3. So these will be also known as principal stresses because no shear stresses is there. That's why sigma 1, sigma 2, sigma 3 are denoted. So the state of stress consisting only hydrostatic stress is called a hydrostatic stress state. Means if anywhere the word is written that element is under hydrostatic stress state, that means there is no deviative component, only hydrostatic stresses are present. So this is the meaning of this hydrostatic state stress. So next, the hydrostatic stress is a measure of pressure exerted by a state of stress. What is the pressure exerted? That will be the measure of this hydrostatic stress. Pressure, what pressure does? Pressure acts so as to change the volume of the material of the earth. It will try to change the volume. So we got to know that hydrostatic stress is doing what? It is trying to change the volume. Okay, change the volume. Hydrostatic stress. Hydrostatic. Okay, change the volume. But we know in plastic deformation, there is no change in volume. Means V1 equal to V2, or area 1 into length L1 equal to area 2 into L2. This is the condition satisfies plastic deformation. So you can ask that if there is change in volume, what is that condition known? That is known as elastic deformation. Elastic deformation. So we got to know from here that hydrostatic state is changing the volume, or it is in the elastic deformation zone, or it will result in elastic deformation and no plastic deformation, because it is changing volume, and we know in plastic deformation volume is constant. So one point is clear from here. Okay, what that hydrostatic stresses do not cause plastic deformation, it causes only elastic volume change or elastic deformation. Okay, now let's see what is the condition of plastic deformation. For plastic deformation to occur, shear stresses are required to cause shearing of atomic planes. You are deforming the shape, so you are shearing the atomic planes. That means, or rearrangement of atoms without change in interatomic distances, because that volume is not changing, so interatomic distance won't change, but just the atoms will rearrange into different position. Okay, so that means you need a shearing stress. So as shear stresses are absent in hydrostatic state of stress, we have seen there will be no shear stresses in hydrostatic state of stress. Therefore, no plastic deformation can be induced and only elastic volume changes occurs. Okay, again I am repeating the same thing. Okay, so therefore it can be assumed that deviation of stress state from the state of hydrostatic stress determines whether the material yields. If there is any change from this hydrostatic stress behavior, if there is any deviation from this state, then we got an idea about the material yielding property or start of plastic deformation. Okay, now let's see something about deviative stress. The state of stress that causes plastic deformation is called deviative stress, state of stress. Okay, and this component can be obtained by reducing the normal component by hydrostatics, that is sigma xx minus sigma m. You just write down sigma xx from the previous expression, it is not written here, and this is the condition of, this is known as deviative stress. Here the first stress invariant, that is I1 equal to 0. You these things can be found in the books, so no need to see here or derive here, because we have to solve this question and understand the concept by assuming that these things we know already. Okay, so first stress invariant condition, if becomes 0 for this, if you add these three condition trace, then it comes to 0. So this condition is known as pure, or we can just see, hence the deviative state is also known as the pure shear state of stress, or distortional state of stress, or simply as stress deviator. Okay, pure shear stress state, this deviative component. Okay, so this deviative stress is a measure of shearing exerted by the state of pressure. That was the measure of pressure, and it is known as measure of shearing exerted on the state of stress. So shear stress tends to distort a solid without changing its volume. There will be no change, only distortion of the shape will occur, and that is known as plastic deformation. Okay, so we got to know that which component is going for plastic deformation and which component is going for that volume change. So from till up to the discussion, we got to know that stresses along this hydrostatic component do not cause any plastic deformation. This is true. Okay, because this hydrostatic component will do elastic deformation. Okay, second, this deviation component will cause plastic deformation. This is true, we have seen. If anybody want to do plastic deformation, then you need a shear component. Shear component is given by deviation component. Okay, let's read further. So now we will see the Tresca criteria. Just direct formula I am writing. No need here for the derivation and understanding of this Tresca criteria. We will just see the graph. So Tresca criteria says that yield criteria indicates that the plastic flow will begin or material start to yield when the maximum shear stress reaches the critical value K, and critical value K is denoted by sigma 1 minus sigma 3 by 2. Or when you draw the graph of this Tresca criteria is denoted by this dash lines, okay, and von Mises is given by this, okay, this elliptical surface. This thing you have studied in yield failure theories, okay. So this was the graph in 2D. If you draw in 3D, so this will be in form of a cylinder, and this elliptical surface of this is denoted here. So it is a cylindrical, okay, and this center line. And if you move outside, means you are increasing the stress values. So resultant stress value when it reaches this surface, that means plastic deformation has started. Means if your point is inside this cylinder, that means elastic deformation only, elastic deformation inside this cylinder, okay. Inside this cylinder means only elastic deformation, and if you state or the resultant stresses reach the surface of this cylinder, that means that plastic deformation has started in the material. So this is the means significance of this diagram, and you can read out from this also that yielding or plastic flow will begin when the maximum shear stress reaches the critical value, and critical value is this condition. Critical value means inside this cylinder material is safe, not failure, because failure will begin when it has started to yield, okay, then we will consider as yielding will start from this point. So these things are written. So notice that failure yield criteria can be another most important point. This yield failure criteria can be given for both plane stress and plane strain condition, okay, for both conditions. But in sheet metal forming, just note down the word sheet metal forming or metal forming, most analysis is done assuming plane stress condition, because along thickness direction sigma 3 is assumed to be 0. So plane stress condition in sheet metal forming, plane stress condition, okay. So in von Mises you get a ellipse equations and proof you can get in the standard book. But what is the physical significance of that ellipse? That stress inside the cylinder represent elastic behavior, as I earlier told, and yield or plastic deformation begins when the stress level reaches the surface of the cylinder. Just note down, begins from that point when it reaches the surface of the cylinder, that is yield or plastic deformation. So let's now go back to the options. So we have seen these two options to be correct. Now it is saying plastic deformation will occur only when resultant stress reaches the von Mises cylinder surface. Okay, von Mises cylinder surface. So this is also true, because after reaching the surface, plastic deformation starts, and means inside the cylinder only elastic deformation. This is right. Means A, B, C are right. Then we come to D. D is given Tresca is plane strain case, but here it is saying metal forming. So in sheet metal we have seen that it is given for plane stress condition, okay. So this is wrong in respect to metal forming. Just note down that in respect to metal forming and that to sheet metal forming. So the correct option will be D option. I hope you enjoyed the lecture. Some things I haven't gone into the detail because that comes in the theoretical lecture, as we are here to see the explanation, assuming that some topics or some concepts or some derivation you already know. So I hope you enjoyed this lecture of today. Meet you in the next lecture with a new concept, with the help of a concept. The more questions you will solve, the more knowledgeable you will get. Okay, because through questions you get to know that how you apply the theoretical concept which you have read in the books. Okay, till then, have a nice day.